I'd be surprised if you didn't after 21 years. I need some tricks to compile myself every morning, and I'm 38, so.
Yeah.
All right, so let's get started. Welcome everybody to OpenCV weekly webinar. And today we have with us Raymond Lo from Intel. He is an AI evangelist at Intel. He's working with the OpenVINO team. I'll let Ray introduce himself.
Hi, everybody. So again, welcome back for myself. This is my second time joining everybody in this webinar. So very simply, my background is I did computer science back in Toronto, so I'm Canadian. If any Canadian here, say hi to me. It'd be nice to say hi to all the people I met. And secondly, I did my PhD.
Good day, A, as they say.
Good day, A, yes. I don't say sorry yet. So then I did my computer vision PhD. So I spent a lot of time doing CUDA, doing a lot of like low-level computer vision. That's why I love OpenCV. I was like one of the very early adopters. So it's my honor to be here speaking about more what the next thing about, because now I'm working on AI side in Intel, and I work with a lot of developers. So that's why today I'm gonna show you some of the tips and tricks, and more importantly, the ModelPlace.AI. I think it's really cool because I think I spend usually 1 hour to get something running. That one really brought me down to 5 minutes. So that is something I think really changed the way I think about how to use AI model today. That's why I'm here.
That's great. And with us is also Phil Nelson. Phil Nelson is the content manager at opencv.org. And you see him every week because he is the one who puts together these webinars and many other things at OpenCV.
Hey, everybody. Yeah, as usual, we'll be doing a giveaway at the end of the show for an OAK-D-LITE, the little tiny 4K AI camera. Yeah. And we'll be doing Q&A from you in the audience. So please use the Zoom Q&A functionality at any time during the webinar, and we'll try to answer as many as we can at the end.
Right. Thanks, Phil. Okay, so let's get started. Basically, today we are going to have a tutorial, which will, Ray will show us the tutorial how to use an OpenVINO notebook with ModelPlace.AI. And I'm also going to tell you about a new feature that was added to ModelPlace.AI. It is super cool. I don't even know whether Ray has seen that feature, so it's going to be
I have no idea. We'll see.
Okay.
You surprised me again. That's all good. So should I take it away? Maybe I'll start sharing my screen and then pop it up. Okay. Let me know when you're all ready. All good?
Yeah.
Yep. So let's get started. I would like to tell a little bit of story why we're here, what OpenVINO is about if you have never used it. I'll keep it short and quick. Right after that, I'll do a tutorial exactly how I get the results out from it. So, well, first thing I want to talk about were the lessons I learned, or well, I'll say we all learned when we're doing AI or in computer visions. So remember, I talked about many years ago, I think almost like 15 years ago, I was using OpenCV. So one thing I really love about OpenCV and why I used all this tool were, it was so simple to use. So I was like a student trying to get something done. The face recognition was one of those eigenface things. Like I never figured out all the math, but how does it look like? What can it do, right? With that, I can run it in minutes. I was surprising my professor. How can I get running? I was like, OpenCV library call. I was like, okay, fine. What can I do with it? Then we start building project. It kicked off a lot of momentum because of the simplicity. And more importantly is I was not reinventing the wheel how to do eigenphase, how to do this from like low level, because as a student, I never get it done, right? You know, I have like 10 courses and I have to optimize the code, not gonna happen. So given all this constraint, I think the open source community was very helpful too. I was asking a lot of questions online. And these are real lessons because without those, I don't think I'll be here today speaking to you because it really took me off from a nobody to somebody to maybe I published something to be somebody of somebody in this field. This where I think OpenVINO and OpenCV, all these are very aligning together because OpenVINO I work with today is a visual inference and neural network optimization library. What does it mean to you is today when you're running a lot of different AI tools, this one is the one that gives you the boost in performance. So oftentimes I say that that's your energy drink for tonight. If you want your code to run 2x faster to deploy it, there's a likelihood of a chance that you'll get what you need to get it out to the market for you. And this alignment is important because I think we all work together in this, not just me, with the partners. So we always think about the whole journey, how to get it to someone's hand. I'll keep it simple. Here, take a screenshot, guys. I'm not gonna go through the entire thing, right? Here's the introduction. But if you have any questions, come to me, because this is where I see how we connect all the dots. And you can see OpenCV is one of our key library to enable you to build things. Why is it I'm here? Let's slow down a little bit. You have seen one of this before, right? Remember I talked about, it took me hours, no jokes, hours to run anything, and they're not even optimal. They're not even fast enough to fulfill my goal. So that's one of the fragmentation we felt at Intel, and I think ModelPlace.AI was one example, how they take away some of the fragmentation and centralize it into one place where we can download a model, have a sample code, and run it. It's as simple as that, right? And today I'm going to show you what I did to get there.
Actually, even before you download, you can actually upload a picture to try out the model to know whether you even want to download, right?
Right. That's
that's
a feature. Sometimes I forgot. That was super cool. I got to show you. Yes. I'll go through the entire process, like what I learned, because you will start like from nothing to something in such a short amount of time instead of going through the bugs, right? So I think that is something I really enjoy. For you to get started, however, I think there's a little bit of the requirements still, but it's very simple. You have a CPU, you have a Windows, Linux, or Mac. I'm using a Mac, by the way, right now. And if you have Python 3, it's pretty much ready to go. Because all you need to do is, if you have the OpenVINO notebook installed, which is a 3-step process, I'm going to send you the link later. So basically, you set up your virtual environment, clone the repository, and do a pip install. Once you have done that, you already have OpenVINO environment set up on your machine. Then you can use the sample code in the ModelPlace.AI. Then it'll work. It's like magic. These two connected, like they marry already. I don't know how, but behind the scene of, I don't know what happened. It's like super, super tightly integrated. So I'm not gonna go through more of this. I gotta just go directly to the source code now. So are you guys all ready? I gotta show you how it works. All right. So let me toggle to my browser and how it gets started. So the 2 things I would like you to remember today. First, go to this website, ModelPlace.AI. This is where you will find out all the fun models you can try. So I feel like these will be endless of them because we will keep going through. You can do sign languages, you can do text spotting, which I'll do today. You can do face, you can do body pose, which I find is really cool as well. So you can go through each of these and see which one fit to your projects. And for me, I think I'm with Intel, so I often go with the one with ModelOpenSuite because I'm familiar with, but definitely go with any of them that fit to your needs. So for this one, for example, you can test your model. So one thing that you may not know is like you can drag and drop and get your results out from here. And I'm not gonna demo this. I want you to try it. So I'll leave a little bit of teaser for you. Or drop your own image, and then you see what happened. But more importantly to you today, right now, is how do I look at this model? What does it mean to you? So first thing is I always start from the left side. Look at the summary. Look at the what architecture they use. But to me, I think I want to try it. So before you read more, you want to say, how do I set it up? So first step I would always point to people now is go to the notebooks. This is the repository I just talked about with the 3-step installations. So this is something we maintain at Intel. So we always test it with CI. So if any problem, you can always like file an issue. We'll try to follow up for it. And
CI means, stands for continuous integration for those who
that's
aren't
right.
aware.
Yeah, I shouldn't use acronym. That's one of the things. Yes, we always test your code behind the scene. That's how I always call it. So that's exactly. Every night we have an engine just like, let me pull all the project down and see if they runs on a setup. So we test on Linux, Windows, Mac. So there's a lot of example here and that you can play with. But I think the key is you can always treat this like an IDE, which is an integrated developer environment. Am I even right? I don't even know anymore IDE. I use it since, anyway. So that gives you the confidence of, okay, if you can get this running, like any of the Hello World, that means that you can get it running on the ModelPlace. So again, this is a setup. I'm not gonna go through it because I've done it last time as well. This time I'm gonna show you, once you start building it, how would that look like? So first is, let's say validate your work first. Let's say you have the hello world, make sure this runs. So this is my one, like this, the first demo, right? Get this running. Once you're up and running, okay, it's basically this one, what it does an image classification, find out what's in the image. It says the golden retriever. No, it's a flat code retriever. Good. So once you're at this step, you're ready. How did I do that just now? You go, this is what happened after the setup. You have something called the Jupyter Notebook interface. So this is running in a browser, but behind the scene, which I can show you, is in the command line. I set up all this and you run it, and this is how I run it. Oops. Yeah, I've been testing. I should be showing all this, should I? I've been testing my work, eh? So this is how you run it. One line of code. I test everything before I show up. So, whew. So this is how you get this interface started. Once you have this interface started, now what you do next is, so let's say I want to do the one text spotting. So I create this code already, but let me show you how I did it. So after you test the model, you say, hey, this is really cool. I want to follow the instruction, right? So what you need to do now is get the model. When you click on it, you download it for the on-premise. So on-premise, so what it will do is it will download the pip file, which is the installer file, or the wheel, pip install, with the wheel, I call it the wheel. I don't know, so many acronyms, guys. Wheel, I don't even know what that stands for. Anyone knows? Let me know, okay? Maybe it's a question to you.
Is wheel an acronym? I'm not sure.
I don't even know anymore. So many acronyms in my life. I know EXE means executable, right? So at least I know that. So
I don't know for sure, but I mean, a Python wheel is basically, it's a package that you can install using pip, right?
Exactly.
So that's the main thing to remember, but I don't remember whether it's an acronym.
Exactly. So once you have this environment, the way it works is I create this folder. So this folder is brand new, ModelPlace.AI. I put it in there. So after you create this, first thing I do is I put the file here. So you can see what I just downloaded. Text spotting. Why I do that is just, it's easier to organize your work. I always think this way. So I downloaded a while back a long time ago that's modified. Anyway, so as you can see, the file is in here. All you need to do is do the installation is run this one line of code. So once you're inside this environment, you run this line of code, magic. So you have the model, you have all the APIs you need, and pretty much you're set to go. And that's the first step. That's all the installation you need. Because like once you have the notebook, you basically have an IDE that you can already play around with. You already have OpenCV, you have Jupyter Notebooks installed, you already have OpenVINO. So that took away all the pain, because remember my first step, trying to get it set up, the code is outdated. This is not. So that's a good step. So once you have that, the second step I really want people to just really read it through is how simple the API is. So again, there's a lot of code here, but the actual one that you really have to memorize are these two, right? So this is where the engine is, the inference model and the engine, the device and all that. This is where you will do all the computations. And behind the scene, I didn't take into the open source yet. It's part of OpenVINO kind of engine too, because I can tell the performance pretty good, right? So then what happened in there were, if you're running this model, these are all the line of code you need. And the rest of that I put in were just for visualization. And if you wonder, where did I get this code? Indeed, let me toggle back to here. It's come from here. So they already give you a system use case. I say system use case means you'll get the input and output, and you get an array of the answers, right? But you want to visualize it? Here we go. I give you some extra tips today so you can see the results as well. Because you get an array of text. When I first got the array of text, it's like, let me decode it. So my brain was like on fire, trying to say, okay, position XYZ, I try to remap the whole thing. And after you saw it, I was like, okay, it's actually working. So for example here, how it works is the same interface I was using. You say run all cell. So what's happening now is, okay, I ran the results first and I'll explain how I get that results. So what happened for text spotting means in a scene, it will find out anything that looks like text, right? It actually worked with Japanese as well. So I gotta do a live demo on this. It's a bit slow because it's not like perfectly I optimize it yet, but I can show you that I can pull out my painkiller, I recognize it. I can pull out my Japanese candy, I'll recognize it. So this is pretty fun. I will leave that as exercise, guys. I don't want to ruin all the fun, but I'll try a little bit. But any questions so far?
Just to a little bit, give a little bit color to this this discussion. Now, you have to compare this with other ways you get a model, right? Let's say somebody has published a model online, right? Compare that pain that people have to go through to actually, you go to that, it may be in TensorFlow or PyTorch, you download the code, you have to get the right version of one of them, and then you get to try, and you're not sure 100%, whether this model is even useful for you or not, right? And I like to give the story about a hypothetical story about a person who's trying to run a person detector, right? So they run a person detector. There are so many options. There's YOLO V1, V2, V3, V4, V5, and we have CenterNet, and we have many other, SSD-based people detector. Which one do you choose, right? And first of all, there is no one place where you can actually look at, or there was not one place before we released ModelPlace.AI, where you could visually see, oh, this is what it is going to be. You can try out the model, right? And then the other thing is that let's say you want to try out 5 models, you have to download each one of them and work through all the installation problems with them. And then you can try them out. And then you have this painful process of trying to figure out, which one works better, right? Which one is better? And it's not like, oh, just use YOLO V4, it is better than everything else. That's not the case, because it depends on your use case. Sometimes you may want something which is for mobile, right? And even within mobile, there are several options to choose from. Which one do you choose? Our goal is to make that choice very easy for you, right? Think about the effort that would have gone into to just what Ray is mentioning. You just pick this piece of code, copy it, and it runs. And you can run this for any model that you want with almost painless 5-minute you can spend.
Exactly.
Yeah.
It was the least painful thing I ever done in my life in terms of the development so far. Usually I don't advocate for things like that, but this actually very fast. I was talking to Phil, it's like, can I try? And then in the same day, it's like, oh my God, it's working, man. Like, what the heck just happened to me? So anyway, so let's get back to this. Thank you for the coloring. I heard you have some new feature you're gonna tell me. Don't tell me yet. Okay. I gotta finish this before I get even more surprised. Yeah. So now you start to notice like the number of line of code is very simple. So you read the image, you initialize the model, you define where you want to put it. I think CPU is one, maybe this GPU support. I haven't tested everything yet, guys. I'm not as new as you, but I was very impressed by trying this and getting it running. Then you just process the sample, right? It's just like 3 steps to me. Then the rest, by the way, this is my code, guys. You see, this is my code. The style is different. I say draw results. I didn't document as well, but I just take an image, take the bounding box back, right? Because when I get the results, I look at it as like, oh, that's easy, just a list. So thanks to my CS 101 since my early day, it worked. So I know how to parse an array. Then I get it in. So I draw that in about 5 to 10 minutes later. I debug it as why is it showing this in the beginning? Oh, it does look like some sort of handwriting. If anyone know what language that is, let me know. But there we go. So we finished this, and I was like, okay, this is so cool. What can I do more, right? So I start putting it together, wrap it around, and even make a video version of it. So this one run a little bit slow, just to be warned. And I gotta pull out a painkiller. So I don't have anything that's here yet. I have a piece of paper somewhere.
You have a box of painkillers on your desk?
Yep.
Okay.
F-Fuse. I don't know if I shouldn't be advertising for F-Fuse. But let's say I do a video processing loop. Okay, this is a rough demo, guys. So don't be like, oh, why is it so slow? I just wrap it around to make it working, guys. So, okay. So let's see what happened on this, all right? So let's run all and see what I'll get out from this. Oh, actually processing loop 0. 1 second. All right. Hope Okay, so I have myself with a painkiller right now. Let me make it focus first of all. My camera is trying its best to focus. So it runs in real time, guys. I don't know what to say except that's your big kill. Okay, I'm not advertising more, guys. I'm not a sponsor for that. Okay, just as a disclaimer. But it works with a painkiller, guys. So this is my painkiller solutions. So I don't know. It proved the point. I get it running. First of all, is it the optimal? We have work to do. But I think that's the beautiful part about this, right? A lot of time, it took a lot of people a lot of effort to get to this stage to know what am I looking at? What performance are we getting? Are we even there yet? Are we off by like a huge margin? There's a lot of uncertainty when you deploying something, right? So to me, this is the first very important stepping stone for new developer. As again, my job as an evangelist, I felt your pain, guys. So I hope that you don't feel my pain, that you don't need this jar next to you every day. So let's put it back in.
You know what I have on my desk?
Yeah. Coffee? Double coffee.
No,
Intel
come on.
coffee.
Come on, Ray.
Triple. Oh, come on. All right. So anyway, so hope that proved the first point. But we didn't stop there, right? Because I just showed you one example of how I learned one thing. The other thing I really care about is consistencies. Remember I talked about, this is simple now. That first thing I learned is let's not reinvent the wheel. I want to reuse what I learned to apply to my next model. How does it work? Let's see what we learn is repeatable, right? So what you do now is, all right, I'm gonna go through the whole list of this again. And guess what? I like the model thing. I wanna like dance around it in front of the camera today. So how do I do that? So again, I picked OpenPose because it's open, I like it. And it's something that I know myself in the beginning, a while back. So let's see how I can get this running today. And this is also part of the model, open model suite. So also I'm a little bit familiar with it. So let's take a look if I can apply the same thing. So first thing I do is, again, test your model if you can. So you can just drag and drop or just like upload one that you need and you'll get a result. But what you need to know is like, what is this tracking, right? You wanna know how well does it work? So you start reading the documentation again on the left side, which is like one-page summary, not a documentation with a paper. Usually I read a paper, guys. I don't know, you know my pain. So anyone that does AI right now, you have to read through a paper. It's not 2 minutes work, it's 2 hours of work. So I have like a deck of paper. Oftentimes like, there we go again, guys. So, so anyway, if you guys are interested in reading paper, put the comments there. Maybe next webinar, we can read the paper together. I don't mind at all, but it takes a lot of effort. But I'll show you what usually I look at when I read paper because that was part of my training. But look at the code, guys. What did we learn just now from this one and this one? Anyone can spot one single line of difference? It's only one line of difference. If you do like an A-B comparison. Anyone see it?
I give up. What's the difference?
This is it. You import a different model. The rest of the source code is identical. I was so happy because I don't have to relearn this. Because every time I have a new model, people give me a new way to process it. So this standardized my interface. So every time I run a model, I can just copy and paste my old code. The only difference in caveat is, okay, I need to do to get the model. You still need to know what you want to choose. But okay, that's one time thing. It's not like every time, right? So now I did the same thing. I download the model. So you can see on my local machine, I have something called the OpenVINO, OpenPose, right? So this is the same thing I just talked about. You have to basically do the pip install. Oops. Oh, you see the secret already. Don't worry, you'll see more of the secret. So you do the same thing, right? Nothing new, pip install, same import. And the only difference you have, you're changing the import. So instead of the text spotting, you have OpenVINO, OpenPose. Now the tricky part. You still get the results, but now you have to learn how to parse the results. Again, my CS 101 saved me again, but this one is a bit harder. So it took me half an hour. So this one is a little bit more tricky. So let's talk about what this one will do. And then I actually make this draw function for you. But I'll say for the audience here, I'll print out all the links. Links basically is the skeleton, right? Think about once you have done a skeleton tracking, you have, let's say, all the line that connecting the join and points, right? So I gotta uncomment this and run the whole thing now. And so you can see how I parse the results. So if I would say one thing is, what do you need to get this running to make it visualizable? You need to take a CS 101 to learn how to operate an array. That will be only thing I think is a prerequisite right now. And assume you have it. If you don't,
also point to a very good, you also make a very good point, Ray, that maybe we should be including a visualizer with every model as well, right? That will just make things easy for folks. Yeah.
Yes, I think this will be a good thing because I already roll you one. I don't mind. I think you go just like copy and paste this one, right? Yeah. And at the same time, it's always a good exercise to do a visualizer and learn all the parameters because you start to notice some small bugs. So I think you mentioned it correct. We will provide you, but it's an amazing exercise because I didn't know the score was important. I didn't know until I visualized it. It's like, oh dear, if you don't check the score, you may have a wrong result of, let's say, it's not a human pose, it's some random pose, right? So I can explain all this. So there's some magic number I put in there, but exactly, I think this is something worth talk about here. So here, for example, I put image, and then that's what you get. You get the joints. You get A and B. Basically, is 2 dots. So in space, so you get X, Y, and then they tell you what the locations are. So you can actually very explicit to say, I want to put a ball on your nose if you wanted to. I don't know why. But you can do that right now with this skeleton tracking. So if you put it on your eye as well, I think there's eye. Where's the eye? Left and right eye. So now you have a pointer. So even this one is sufficient to you to build some sort of pointer system using your head if you want to use it for head tracking. Now together with the arm, so you can see like album and all that. Now you can have like a joystick. And I saw people build interface with this. I saw the OpenCV competitions, people doing gyms, so many small things that, like, okay, you get information, but if you understand what the information is about, you can now make sense of it to create applications for fitness, for patient care. I saw it in patient care as well, because sometimes you have people panicking, they move in a certain way. So there's a lot of usage that came from this. So by visualizing it, this is just for example, you download it. I cannot share this, but even work with astronauts, as sky's the limit, guys. This is my like moon landing moment right there. So I don't know, wherever. Next one, I'll say, I'm not done. I'll say, how about black and white? I was like, is it color important? So I start learning about this. It's like, that was me on stage back then. I was like doing augmented reality. I don't even know about my background. Look me up. So I was like on stage trying to figure out things, it was like, that was my augmented reality on the right side. You can overlay cubes. But this is a black and white image. To me, it's like, there's no way this algorithm will work. And it still works. It's like, okay, I don't know how it works anymore, right? So you start to tinker and thinking about, is color information important? You start to tingling with like, what is the sort of the breaking points are? So that's exactly what I think AI learning for a lot of you should be, is to understand the core mathematical issues, right, that you're dealing with. From, let's say, is there color dependencies? Is there any sort of like limitation in terms of resolution? That's just something you should learn very hard so that you're building a model or having the right accuracy to solve the right problem. Last and not least, have you guys seen the baby Ray?
No.
No,
Go ahead.
Some of my favorite.
All right, so I gotta reveal my family secret tonight. This is me before I know what's going on. So, sorry guys, that's my parents and that's my sister, and my brother I think is still somewhere within my mom's there. So it's a family of 3 here. Why I tried this photo? First, I tried really low resolution. Anyway, questions?
You're not the one with the ponytail. You're the little guy.
Yeah, I'm a man. That's right. I don't know. I'm gonna double check my mom.
It doesn't do pose in the womb, I guess, huh?
Yeah, not yet. There should be a baby detection here inside my mom. Like my brother's in there already. That's why I know. So why I'm doing this is I want to see, okay, color doesn't matter as much. So I get the worst possible color image, quote unquote color, is a photo that really, I don't know, barely have any color and barely have any resolutions and barely have anything. So I want to guess how well would this run for multi-pose, not one, but multiple people. So that's what I mean by learning, right? You start focusing on the issue, right? It's like, would this model be able to solve this type of problem? Now maybe my next thing is, hey, it can work with, let's say, multiple people. Maybe I should do dancing videos and tracking the movement, looking at the coherence of the players, things like that, right? So this is how I think about AI today, is by removing all these frictions that is unnecessary, Now you can focus on the mathematics, all the fundamental issues, maybe down to the accuracy and performance issue. That's how I learned. That's how I think we should learn. That's why I like recommending using this tool for you to kickstart your journey. Any questions so far? I think I show a lot, and I want to show one last one before I go.
Yeah, let's keep rolling. You're doing
I,
great.
I also think, there is a philosophical thing. When I was starting with computer vision, or even programming, right? I came from a C++ background, and then these new languages started coming up like Python and even Ruby, etc. And they were so easy to use that I almost, hated them, because anybody can use it now. And how do I, it's
I get a job.
yeah, it's like it was just too easy. But it was, when you're young, you don't have the perspective in life. And that's the way I used to look at life. I have this skill in C++, and now somebody with Python skills, which is, I would look down upon them, because they don't know anything about memory management. I can write in bare metal C, right, and allocate my own memory and stuff like that. But once you grow up, you have that perspective that the easier you make things for people, there is a large group of people who can contribute to, they'll basically stand on the shoulder of giants and push the technology further, right? They will push it in ways that will surprise you, that it will completely astonish you how, because now let's say an artist who has very little knowledge of AI, or Python, barely knows Python, right? They can take this and create beautiful art out of it, right? And as an engineer, with not much artistic skills, that would surprise me, right? And that's what we should push for: ease of use, push it down to a level where people are building on top of it. The technology becomes invisible, right? You're not thinking, you're not working with the technology. It becomes invisible, right, to you. And then you're using it for doing what you want to do. Same with the computer, right? I mean, you're not working on your computer. Some people like to work on their computer, which is fine. But most of the people use the computer to do other things, some creative work, some non-creative work, whatever it is.
With it instead of on it.
Yes, exactly.
Exactly.
But I just wanted to give a perspective, because that was how I used to think, when you're young and you think about yourself only.
Very true in some way, because I learned CUDA. That was the hardest thing ever.
Oh yeah.
Anyway, so I cannot explain the feeling of how hard that is when you want to debug a line of code in the GPU. So feel free to read my PhD. I put my source code there just in case I forget it. So it's there. It's all my pain and sweat. So it's no jokes. It's real. I put it in my PhD. And then my supervisor is like, why put so many lines of code there? I don't know where to put it. I don't want to lose this. This is my sweats. You have high level everything, but this is my sweat. So I put it in my PhD. The appendix was like about 50 pages long, so go for it. So, and they're still functional at one point. Lastly, I think now, of course, ease of use is a very important theme I talk about. I talk about simplicity, reinventing the wheel, and open source, right? So let's get to the last point I want to talk about today is why I'm working on OpenVINO, a little bit of linkage to, if you want to go beyond this stage, you're not done yet. Because now I hit a lot of problems that may start to surface because I actually have access to this now, right? How can I go deeper? Can I get even better performance? Can I analyze the model a little bit better, right? Let's get to the depth of it, because now I already have some information I learned about this model. So the last one I'll say is, let's say today you're really interested in going beyond. I call it going beyond for the last stage, because after this stage, the only thing left is you have to train your model from scratch, basically. So like, you want to go to that far, let me know. We will do another tutorial on that, how far you can go. But this is where I think the last shot before you go really crazy on the model. We call it post-optimization. So what it means is now you have this model now. I want to squeeze every bit of this to run on my machine so that I'm not killing myself. So to optimize this with Intel, what we provide is a model called FP16 and IN8. It's a process, we basically optimize it again so that it's a quantized, so fit on an integer floating, instead of using floating point, using integer to do a lot of computations. For a certain region, not everything, there's some floating here and there. But why is it important? 1 plus 1 is 2. 1.00000 plus 2.000 still 1 plus 1, right? 1.1 is like, you don't need all the accuracy sometimes when you don't need it. So this helped the computer significantly to get the performance you need. So today, I'm not gonna walk through everything. I always want people to say, hey, Ray, wanna talk more? Tell me next time. Because I always wanna hear from the feedback what you want to hear. Very similar, this is a bit more complex version of what I show. It's in the, what do you call it? The OpenVINO notebooks. Again, please go into there and then check it out. So again, you have all the access to like very down to the nitty-gritty level, but more importantly, I show you a demo that runs in real time. So I'm ready for a dance, guys. So spare with me if you never see me dancing. Right here, real time. Why not, right? So you can see me rotating. Leg works, by the way. I cannot show, sorry, not long enough. I don't know how far I can go. Oh, I need to stretch more. But anyway, the key is it's working real time. By the way, it's only 20 FPS. On the browser, guys.
Yeah.
But the key is it can run up to 30. I'm running Zoom right now with like video streaming. I've like done everything except this. So you will get a lot better performance if you do it on your own machine, right? I get over 30 FPS on a Tiger Lake machine, on a tablet. So this is something I would love you all to try. And then really now bringing the power, right? Like all the AI stuff all the way down to your fingertips at real time. Remember, I promised real time. I wasn't joking, guys. See, I delivered my promise. And that is what I think you all have to try. This is as real time as you can get, running on the web browser. And you can try tonight if you're interested. All right, any questions? And I don't know, it look a bit weird. Let me make sure that I can rerun this so I look nicer. Okay, let me do a screenshot of this. Okay,
nice.
I took a
all right, so
of you taking a screenshot.
Yeah, so this is I think that's what I want to teach today. That's it. How do you follow up? Let's do a summary very quickly. Again, ooh, what happened to my website? Even my website is lagging. My computer is like, cannot do all this, but it's all good. Star me, so that's one way to give me feedback. Watch this, and discussion. Send me questions there so I can help you to support better. Sign up for ModelPlace.AI. Really learn all this model. And I heard you have some tricks to me I haven't heard yet. You gotta show me what's new. I don't know what that is yet. But this is, I think, it's like my shopping cart right now before I do anything. This is my go-to before I even try to run someone else's demo code. It's just too much pain in my life so far. So that's where we at. And lastly, I think for all of you, if you're very interested in OpenVINO, that's the value proposition. Follow me. Today I showed this demo. It's real. I have Banana as well if you're interested. And even a 3D dab. So there's a lot of things that in there. There's 300 plus of this. So if any questions, come to me. And that's my baby Ray. Take a snapshot of this. If you have this secret photo, I'll talk to you. Sounds good. That's it. Please also download and register to get the newsletter. I also host separate webinar from time to time so that I don't bombard OpenCV all the time, so they can learn more about the toolkits that I'm teaching every day. Sounds good?
That's great. One other thing I wanted to add about quantization, you mentioned that it speeds up things because, int 8 is obviously faster than floating point operations, but it also decreases the size of the model just because the storage requirements are low. And sometimes that is a big deal when you're working with embedded vision systems. You may not even have enough memory to fit in your model so it works. That's also one other big reason to go down. And
if you're very interested on that, Google posts training optimization, OpenVINO. We even do the pruning, we merging some of the operator. So we actually usually squeeze the size down a lot, like exactly what you mentioned. So we do a lot of tricks that you don't have to do. I don't think you should do it. It's just so hard to get it right because a lot of testing involved, engineering involved, mathematics, your validation. So I would recommend people try it first before you jump onto the wagon and say, I need to spend my next 2 years of my life to do it. It's like, wait, guys, wait, hold your horses, right? That's my answer to a lot of you.
Yeah, and we OpenVINO, in our consulting work, OpenVINO used to be, we knew about OpenVINO, but we were not, it was not part of our pipeline. So a couple of years back or something, we ran into a project where we had to do something real time and we were getting about 10 FPS. I could be misremembering the number, but that's approximately. And we had to get it done in real time. And that's when we said, okay, let's try OpenVINO, right? This is going to run on a CPU, and we did it, and we got real-time performance. So 3x we got just, and almost no decrease in performance. So now it is part of our pipeline. We build the model, and every time we run it through OpenVINO, if it is on a CPU or a VPU, then it definitely goes through OpenVINO. And yeah, so we also on Learn OpenCV, which is our blog, you can also see, Phil may be able to pull that introduction to OpenVINO. We have a series of 4 posts which walk you through all the OpenVINO stuff as well, right? But with ModelPlace.AI, it's already optimized for you, and everything has been done for you. You don't have to necessarily do any of that work, right? But under the hood, we use OpenVINO for optimizing our models. That's something people should be aware of.
Mm-hmm. Perfect. Well, thank you. Hey, you still owe me that trick. What's new?
Oh, yeah, that trick. Yes. Let me share my screen.
I want to see.
Yes.
I have good memory on this one, at least.
Good. Thank you. Thank you.
Thank goodness somebody does. I forgot too.
Yeah.
All right. So this, this is ModelPlace.AI, and we are looking at Tiny YOLO v4. This is the page for Tiny YOLO v4. ModelPlace.ai/models/32. That's the model. Now, if you go down all the way down to this page, we have what is called benchmarking. So we took all the models that do similar things, and in this case, we have CenterNet, we have YOLO v4, YOLO v3, we have NAS FPN, and we have Tiny YOLO v3, right? And you can see the performance in one shot, right? You can see the performance of all of these. This is basically a benchmarking tool. We ran all these models on the same hardware, and we used a very low power hardware. It's some instance on Amazon. You can know the details when you go to the website, but they're all run on the same piece of hardware. And now you can see which model you want to choose, right? On this axis is the performance, the frames per second. And you can see that YOLO v4, Tiny YOLO v3 do very good. They are very fast, but so is CenterNet, right? Although YOLO v4, a lot of people have not heard about CenterNet. Pretty much everybody has heard about YOLO v4. But if you look at this benchmark, you will know that, CenterNet is actually very good in performance. It's also very high in quality. And for different models, we have different notions of quality. In our documentation, you will know exactly what it means. But the information is out there. And now you may be wondering, what is the size of this bubble, right? If you actually go to this, hover over this bubble, you will see that, the performance we got in this low power device, or not low power device, computationally low power device is 58 frames per second. The quality is 0.33, and it takes this much RAM. So, YOLO v3, Tiny YOLO v3 versus Tiny, CenterNet, there may be cases, even though this has high performance and high quality, you don't want to use it because it uses about 1 gigabyte, 1.8 gigabytes of RAM, instead of this one, which uses only 344 megabytes of RAM, right? So depending on your hardware, you may say, this is not even a feasibility. It's not even feasible for me to use CenterNet, but look, this quality is Tiny YOLO v3 quality is very good. I'm just going to use that, right? So this is the surprising new thing, new addition to ModelPlace.ai. We have actually not publicly talked about it. This is the first time I'm publicly talking about it. By Monday or Tuesday, we are going to do, we'll publicize it more.
It's what's called a soft launch, folks. Little inside baseball there.
That's right.
Right.
But very interesting tool, because it's one of those things that we not only use for others. It's not just for others. It is also for our internal team, right? The experts in any team, you have these super experts who are always busy, but you also have other people on the team who may not be, may not have the breadth and experience. for them, this is an amazing tool, right? They go and check it out. Oh, this is the tool I have to use. And, when they come and talk to the expert programmer, they don't look like, oh, they have not done that research. You just go and check this out. Oh, this is what, this is the model I have chosen, and this is why, right? ModelPlace.AI told me that this is the right one to choose for this task. So it is actually very useful.
I like it.
Yeah, and also, you instantly get, when you look at this picture, you also instantly get what are the other models that I can use for the same task, right? So for example, you had come with, like I said, that YOLO V4 is a popular one. So many people know about it, but you come to this and you see, oh, Sentinet, what is this? I have never used it. And you can go and explore that. And not only that, you click on this, right? And you find it. You download the whole thing and, do the
or
same
you can
thing.
even just drag and drop to test with your own data right there on the browser without having to download anything.
Yeah, that's right. And this is a picture for the soccer fans.
That's true.
You mean football? You're going to get us in trouble, Satya.
That's right. That's right.
Okay.
International audience. Okay, that's the one that I wanted to show. And there is one other little thing that I wanted to show, not related to this, but we our Kickstarter campaign is going on, and we have raised more than 600K with the help of more than 5,000 people now. And things are moving so fast. Just imagine, I had this video recorded and I have not released it for 500K, right? Celebrating 500K. I just got so busy that I slipped by a day or so. And now that video is irrelevant, right? One of the things that we did for that video was we pointed OAK-D-LITE, this OAK-D-LITE, at our screen, because I wanted this little thing to see for itself what it is doing. It's making history, right? And it had to see for itself. So we wrote a little code, and it is text detection and recognition. And we pointed at the camera, at the screen, and let it run. So this thing that you're looking at, it is that moment when we crossed 500K, and we coded it so that once it reaches 500K, the color changes. Yeah. So it was detecting in real time. So there's detection and recognition. Both of those models were running on this device while the device was looking at the screen. So that it brought tears to my eyes.
It's deep, man.
I look at Painkiller, you look at Cash. It's funny. It's really funny. I don't know.
Yeah, I'm not going to show you guys the bottle of Jameson next to my desk.
Congratulations again. Yay.
Thank you.
Well done. Thank you.
We'll still release that video. I'm a little bit late, but we'll still release that video.
Talk about over-engineering. This is the most over-engineering thing I've ever seen in my life. If you ask me, that strings is awesome. I love it. All right.
The device... The device had to see for itself. What do you mean? You don't care about its feelings? It had to see for itself.
Oh, Jesus.
What if it gains consciousness and says that you didn't, when I was being born, you didn't show me. Yeah. It's like recording, the picture.
Right. Yep.
When kids are born.
It learned very well now. Should we answer a couple questions here? Yeah. Someone asked me about running on my PC. Yes.
Usually on my laptop. What we do is we'll do our giveaway first. So Satya, would you like to tell them what they'll win if they answer the trivia question today correctly?
It's a very big surprise. Nobody could have guessed it. We are going to give away an OAK-D-LITE, and if people don't know about it, go to our Kickstarter campaign, opencv.org/Kickstarter, and you will know everything about it. Basically, this is AI camera, which can run neural networks and do depth estimation in real time. And it's so small, you can hide it behind my fingers. And it's literally, the weight is 61 grams, which is less than 3 AA batteries. So check it out, and you will get, if you answer this question correctly, and you're the first one to answer, you get this thing for free. You just have to wait, because we don't have a lot of these lying around. By the end of the Kickstarter campaign, which is in 24 days, we'll be ready. And at that time, with all the other backers, you will receive it. Officially, the date for release of these things is December, but we are trying to push hard to get it earlier.
All right, thanks. So in case you haven't joined the webinar before, the way this works is I'm going to ask a trivia question pulled from Ray's presentation. You're going to answer that, excuse me, you're going to answer that question in the chat window here on Zoom. The first person that answers it correctly on my screen will win that incredible little 4K AI powerhouse, the OAK-D-LITE. So
I'm monitoring.
fingers
watch the chat now.
on keyboards, folks. So Ray used a specific model for pose estimation. What was the name of that model?
Jesus Christ, someone's fast. What?
I know,
How?
every single week, man. It's not, it's like they're inside my head.
What? What?
It should be.
Again, I was like, what? How is it possible?
Yeah, it looks like Partha got it. Partha's won a couple times here. We might have to retire your trivia answering capabilities. You're too good at this.
You know how these high
The answer was open pose, folks. Open pose.
Right. That's right.
you know how these high frequency traders work. They have these so they have this facility which is very close to and they have the same length wires. You know, all these trading desks that they have been provided with the same length wire up to the last millimeter, so that they have the exact same advantage. We cannot provide you that that level.
They're fighting. Yeah, they're fighting for milliseconds for sure.
Yeah.
We might have to add some new rules. We got some repeat winners. We do love our people that are here every week. We really do appreciate it. But so we'll be in touch. Partha, thanks for getting the question there. Let's move on to some Q&A. I've got a couple flagged here for.
Is it Partha again?
So yeah.
Is the same person?
Amazing. So let's
prediction algorithm.
Let's move over to Q&A here. Somebody asked where they can find the earlier sessions recordings, and this one. Those will be on YouTube. I just dropped the link in the chat there. The OpenCV channel on YouTube. Partha, who won our trivia contest, asks, where do model weights come from ModelPlace, and are they included with the downloads?
The model weights? Yeah. So these are trained. These are basic. A lot of these models are publicly available. We are just packaging them so that they are easier to use, right? So they are published by the original people who published the models, right? And if there is a specific version that we have optimized, etc., yes, the model, when you download the Python wheel, it will have the weights, etc., in it. There are some models which may not be public, but you will always get, whenever you download it, you will get the model weights with it. There are some very specific ones, right? For example, there are some uncommon ones. The goal of this thing was to get the fat tail of the distribution. We can always get a person detector from everywhere, but we want it to be a place where people share a leaf detector. Let's say somebody is interested in leaf diseases or something like that, and only 1,000 people in the world are interested in it. But there is no. We want them to be. We want it to make it easy for people to distribute it through this channel. So we have a lot of free models. Basically, if you want, you can contribute model to ModelPlace as well, right? It would be a marketplace. Eventually, there would be paid models also, but if you have a free model that you want to publicize to the community, this is a great way to contribute as well.
Yeah, absolutely. It's a great resource already, and new features are getting added all the time, like we showed today. That benchmarking is so powerful, especially if you're new to some of these models and you don't necessarily know what's even out there. Now you do.
Yeah.
And it's you know exactly how they work and how fast they are and everything. Charles would like to know, are there good models for getting the pixel height of text for processing?
Pixel height of text. I don't understand the question very well.
Are they asking how big is the bounding box? Is what they asking?
I think that may be it. Yeah.
Yeah. So when you run a text detector, it will give you a bounding box, and you can look at the height of the bounding box, and that would give you the pixel height.
Got it.
For each bounding box.
That's right.
Mario Bergeron, our friend here, who's here every week, would like to know where you can access the notebooks that Ray used. Are those available anywhere, or will you be uploading them anywhere, Ray?
The one that I just showed you, I would give a link to Phil, so then it will be like a private download first. Will be officially in the GitHub notebooks in the future. But the reason I show a lot of simple screenshot today is you can even type those in like 5 minutes. So oftentimes I almost like encourage people to try an exercise too. So I'll do both. Go to the GitHub OpenVINO Notebooks, and you will find the pull request in about a week or two.
So we'll share it in the we'll share it when we release this as a YouTube video. Right. We will share it in there.
You have a download link as well. Yeah, but also GitHub is the go-to because we update it all the time.
Richard would like to know, is OpenVINO optimized for Intel hardware, or can it also run on like AMD or NVIDIA GPUs?
Good question. Give it a try. We have the whole open source. I've seen people porting things to different platforms. So even we have an ARM plugin. So we do have a lot of plugin architecture that contribute by the open source community. So you can be one of the person get it running. So if you want to run on Raspberry Pi ARM, actually you can do that if you're interested.
Awesome.
Right. There's a lot of architecture in there you can play.
Ross would like to know, does OpenVINO work on the new M1 architecture from Apple?
I wrote a blog on it. If you're interested, take a look at Google, Apple M1, OpenVINO, and Raymond. You will find the blog. I tried it. You can give it a try. That's all I can say. Give it.
What's the answer? I'm curious too.
It runs.
Okay.
It runs.
But is it optimized?
I don't know.
Okay.
That's the answer. I don't know if it's optimized code. It's full of virtual layers, so there's a lot of complexity. But I run it over Rosetta too, so that's how I get it running.
Okay.
How is the performance with it compared to like your normal?
I cannot make claims here. That's the problem. But I can only tell you, you should try yourself, and then you can compile natively as well. It takes a lot of time to figure out. So remember, I talked about the ARM plugin. You need to. There's method that you can work around. We already support ARM architecture, so you can run it on a Docker and things like that. So,
but eventually OpenVINO hopefully will come out with, because the joy would be to have it run natively on M1, right? Not using Rosetta.
So exactly. So I tried it exactly what I said. I tried running it on with the ARM architecture with a Docker on the Apple M1. I did an experiment. You can get it running. So it works. It is close to native as you can think right now in terms of when I say performance, because we compare against ARM architecture. Again, this is something I do personally as an experiment. It's not officially released by Intel. I have to put disclaimer, otherwise I'm in trouble. So I just, I don't know. So you have to try as your own fun, like as an experiment. Very, very rough. You can try, but I've done it. So there's enough material out there you can try.
Got it. And just to, the reason I was asking is if you look at the iPhone, the processor in it has specific dedicated hardware for right. And it has 16 teraflops,
right,
16 tops, trillion operations per second.
Short answer to that is it's not trivial. It's the API. If people know, can inform me. A lot of them are behind the wall of the whole Apple development kit. So it's not as freely accessible like an open source project. So I couldn't figure it out during the time I was using it. But please correct me if you find ways to use it. The Metal API is a bit easier. The Metal API provide a lot of accelerations. So TensorFlow and all that, you can see Metal API. So basically using the GPU, the Metal API. So that actually gives a lot of good performance out there. So Intel just recently released the support of TensorFlow and iGPU, so you can do training. Give it a try, guys. Oh, that's new again. I forgot. That's new stuff for Microsoft. So you can use DirectX 12 to run your OpenVINO-ish stuff. Not OpenVINO. It's the TensorFlow with iGPU. That's how I remember. That's the release that was. I was on my LinkedIn. You can take a look.
Great. Very, very and cool. we'll also find out from our side. A lot of people don't know that OpenVINO and OpenCV team. OpenVINO team, a large team is in Russia, and OpenCV team is, a large part is in Russia, in the same city, literally a block away. So they can walk, they can walk to OpenVINO people and ask them. And the reason they can walk to is that they used to work at the Intel.
They are Intel people. That's right.
they're
I have a
Intel
history deck. If you are interested, I do have an interesting OpenCV history deck. I actually ran the code from 2000s and get it running on my laptop today. So
saw
I
that on your
proved the
LinkedIn.
time.
That's pretty awesome.
Yeah, actually, I get it running. It's pretty fun. 20 years, guys. Oh, 21 now. Sorry, guys. 21 years. It still runs. I still run the face detection. I was like, oh man, that get me a back chill. It works. It
Yeah.
works. It's not easy
It's
though.
amazing.
I have to do some trick to make it compile. Just to be honest, there's some tricks here and there.
I mean, I'd be surprised if you didn't after 21 years. I need some tricks to compile myself every morning, and I'm 38. So
Yeah.
All right,
So,
I think we
think
have.
we're getting close to the end here. Do you want to take us home, Satya? You wrap it up.
Yeah, thank you so much, Ray. It's always a pleasure. You know, the energy you bring to all the webinars, it's great, and also the information. So thank you so much for being here.
Right. You're very welcome. Always glad to be here.
And to all our users, thank you also. Really happy to see you always. And you know, just it's my job to mention that OpenCV Kickstarter campaign is running, and if you have not already bought it, please back us. It means a lot to us. Thank you so much.
Yeah, the campaign price is only $89 for that incredible 4K camera.
It's 79 right now.
Right.
Ooh.
Yeah.
And next week we will be back with the
So
Team
good.
Benchbotics from OpenCV AI Competition 2021. Same bat time, same bat channel.
Gosh. You have to download more OpenVINO and sign up too. That's how you do it.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop.
This episode was brought to you by the all-new OAK-D-LITE, currently available on Kickstarter.
If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.